Hello everyone! So for today we'll be learning about the relationship of the structure of atoms to pattern and properties observed within periodic table. The science standard connected to our lesson is to develop and use models to explain the relationship of the structure of atoms to pattern and properties observed within the periodic table and describe how these models are revised with new evidence. And for our essential question, what causes the colors in a firework display? Okay, so to start our lesson, I want you to get your science notebook and I want you to answer your bellwork questions on your notebook. All right, at this point, let me hear your answers for question number 1. What you already know about periodic table. Anybody? Probably some of you will say there are metals in the periodic table. There are also non-metals and metalloids. And that could be one answer. Another possible answer is periodic table is composed of different elements. That's very good. Now, how about question number 2? Why are elements arranged the way they are? Before we can answer question number 2, let us explore more about the periodic table lesson. At this point, anybody who knows the periodic table song? Anybody who can sing the periodic table song? Anybody? Okay, at this point, we will all sing the periodic table song. Your teacher will play the video pertaining to periodic table song. Wow, that was an awesome performance. Good job. Okay, at this point, we're going to have a game. And for our minute-to-minute game, you will use this periodic table. Minute-to-minute game, arranging the elements. The learning objective, arrange elements based on the arrangement that your teacher will tell you. But first, you need to make element tile. So from the periodic table shown earlier, you will choose 10. Your group will choose 10. That is the one that you will use for this game. And then using the element cards that you have, you will arrange the elements based on the instruction of your teacher to play minute-to-minute. Example, arrange your elements according to increasing atomic number. Whatever is the instruction of your teacher, that is the one that you will follow. And you have a minute to win it. Ready? I hope you enjoyed the game. So let us continue our discussion. This is an example, like this one is an example of a periodic table of elements. And each box represents a different type of atom. That type of an atom is also an element. Now, I'm going to give you a quick question. Do you have any idea what is an atom and what is an element? To answer that question, please watch this video. Also, I want you to be familiar with the subatomic particles of an atom. This one is the electron, which is located outside the nucleus. The nucleus is the purple circle here. That is the nucleus. And inside the nucleus, you can find the neutron and the proton. A little information about the subatomic particles of an atom. The electron here is the one that carries the negative charge. And then the proton here is the one that carries the positive charge. And then neutron is neutral. It doesn't carry any charge. All right? The central part of the atom, again, is the nucleus. And outside the nucleus is where you can find the electron. Again, these are the 3 subatomic particles of an atom. An atom is the basic unit of matter while an element is a substance composed of only one type of an atom. So in simpler terms, an atom is a single particle, and an element is a collection of those particles. Also, an element is a substance that cannot be broken down into simpler substances by chemical means. So this is an example of an element, which is calcium. You will notice that there is a number here, and we call it the atomic number. And then there's also a number here, down here, 40.078, that is the atomic weight. Now, you will see the chemical name of this chemical symbol, which is calcium. Calcium is the chemical name. Ca is the chemical symbol. The first letter, which is C, is capital, and then the second letter, which is A, is not capital. So basically, the chemical symbol for calcium is Ca. The atomic number represents the number of protons in the nucleus of an atom, which defines that element. The atomic weight, also known as the atomic mass, is the average mass of all the isotopes of an element, taking into account their natural abundances. We can also define atomic number as the number of protons, and whatever is the number of protons of that particular element, that is also the number of electrons. Now, on the other hand, the atomic mass is equal to the number of protons plus the number of neutrons. So when you combine these two, that will be equal to the atomic mass of a given element. To determine the number of neutrons in an atom, subtract the atomic number from mass number. Let us have an example on how to get the number of protons, number of electrons, and number of neutrons. Say, for example, we have helium. Helium, chemical symbol is capital H, small e. The atomic number is 2. The atomic mass is 4. Now, in order to find the number of protons, we need to know what is the atomic number of that element. In this case, that is 2. Therefore, the number of protons that we're going to write is 2. And like what I said earlier, whatever is the number of protons, that is also the number of electrons. So if I wrote 2 here, I have 2 also here. Now, how did I get 2 for the number of neutrons here? I just subtracted 4 and 2. 4 minus 2 is 2. Okay, now let's have the next element, which is iron. Chemical symbol for iron is capital F, small e. The atomic number is 26. The atomic mass is 56. Now, how many protons are there for this element? So there are, how many? The atomic number is 26. Therefore, the number of protons is 26. And how about the number of electrons? That is also 26, because whatever is the number of protons, that is also the number of electrons. Now, how about the number of neutrons? We will subtract 56 and 26. So 56 minus 26, that will give you 30. So number of protons of iron is 26. Number of electrons of iron is 26. And the number of neutrons is 30. 30. The next element that we have is aluminum. Its chemical symbol is capital A, small l. That's for aluminum. Its atomic number is 13. Atomic mass is 27. Now we're going to determine the number of protons. Again, what did we say? Whatever is the atomic number, that is also the number of protons. So in this case, we will write 13 as the number of protons because the atomic number of aluminum is 13. Also, we said that whatever is the number of protons, that's also the number of electrons. So we will just copy 13. All right? And then now to determine the number of neutrons, we will subtract 27 and 13. That will give you 14. Therefore, the number of protons of aluminum is 13. Number of electrons is 13. Number of neutrons is 14. Okay, this time let us have calcium. So for calcium, we have a chemical symbol of capital C and small a. So capital C, small a is the chemical symbol for calcium. Atomic number is 20. Atomic mass is 40. Therefore, how many protons are there for calcium? We have atomic number 20, so we will write 20. All right? And number of electrons is also 20. And then number of neutrons, subtract 40 and 20. 40 minus 20, that will give you 20. All right? Then next, we have neon. Chemical symbol for neon, capital N and small e. And then atomic number is 10. Atomic mass is 20. Therefore, how many protons are there? All right, 10. How many electrons are there? 10, very good. And then the number of neutrons, you subtract 20 and 10. 20 minus 10, that will give you 10. Perfect, awesome. I hope you find it easy. And for today, you are going to answer an activity or a worksheet pertaining to number of electrons, protons, and neutrons. I know you can do it. Here's another important information that you should know regarding the 3 subatomic particles of an atom. So for proton, its location is in the nucleus. It has a positive charge and a mass of 1 AMU. AMU stands for atomic mass unit. Then we have the neutron. Location is also in the nucleus. It has 0 charge. The mass is 1 AMU or atomic mass unit. And then we also have electron. Location is in orbiting nucleus. It has a negative 1 charge and a mass of 0.0005 AMU. So to summarize everything that we discussed, the number of protons determines the element and its atomic number. Also, the arrangement and number of electrons influence the atom's properties and how it interacts with other atoms. For the exit ticket question, what component of an atom determines the element's identity by defining its atomic number? A. Neutron. B. Proton.